Hi everyone. Today we're going to dive deeper into probabilities and probability events. Now we always need to remember probability is a fraction, it's a part over a whole. How many successes over how many total possibilities do I have? So today we're going to learn how to write out a list of all the events and then pick which ones are successful. So we'll start with a warm up. Okay, we got a spinner, we got some cards. Simple probability here. What's the probability of spinning a 1? What's the probability of drawing a card that's greater than 2? And then what's the probability of doing both in succession? Spinning a 1, then drawing a card bigger than 2. Write down what you think. We'll look at the answers. Okay, so in each case, there's 4 outcomes. There's 4 outcomes on the spinner. There's 4 outcomes on the cards. So probability of spinning 1 is 1 win out of 4. Only 1 is a winner out of 4. Now, drawing a card greater than 2, I could draw 3 or I could draw 4. So 2 out of the 4 are winners, or 1/2 is the probability. Now, spinning a 1 and then drawing a card greater than 2, I can list my sample space where I can spin a 1, draw 1, spin a 1, draw 2, spin a 1, draw 3, spin a 1, draw 4, and see that there's 16 different outcomes. And the ones I want are spin a 1, draw 3, or spin a 1, draw 4. So 2 out of the 16, or 1/8, probability that I do both. We're going to learn some formulas to help us based on independent probability. But at the moment, if you need to think about how many total events are there and how many are successes and create that fraction, that's what probability is. Now, today we're going to talk about the complement of an event and independent events and mutually exclusive events. But it all boils down to how many successes do I have out of how many total? Always make that fraction. So let's explore a little bit. We're going to roll a cube, 6-sided cube. Let E be the event, roll an even number, and let T be the event, roll a 3 or a 5. I want the probability that I roll an even number or a 3 or a 5. I want the probability that I roll an even number and a 3 or 5. And then I want a probability that I don't roll an even number. So write down what you think those probabilities are, list the sample space, if you would like, of all the events, and tell me which events are successful for each one of the problems. Okay, for the first one, it says roll an even number, which is 2, 4, 6. It says roll a 3 and roll a 5. So this should say anything except a 1. Okay, so 5 out of the 6 different numbers are winners. And then we learned in the set theory unit that this is the union, so E or T. As long as one of them or both happens, we're good. Now the second one, what's the probability I roll an even and a 3 or 5? Well, if it's even, it's not a 3 or 5, so those are going to be called mutually exclusive. Okay, can't happen together. If I roll an even, it's a 2, a 4, or a 6. If I roll a 3 or 5, it's not even. Now the probability that I don't roll an even number, I use the complement symbol. So E not, or not E. Okay, not even, not even, not even. So the probability is 3 out of 6 or 1/2. So the union symbol means at least one thing's happening, at least one of these two events. The intersection symbol means they both have to happen. And the complement means that the event doesn't happen, so not even. So mutually exclusive events, like we saw in the last slide, or events that can't happen at the same time. They have no intersection. So even and odd. Maybe an event is roll higher than a 4 and then roll less than a 2. Can't happen together. And complement means that the two events make up the whole space. It is either the event happens or it doesn't. So for example, okay, if the probability of roll less than 3 equals a 1 or 2, so it's 2 out of 6 or 1 out of 3, the complement is roll 3 or higher. So the complement is probability of not less than 3. We can think of it as the opposite. Always put the word not in. And those two probabilities always add up to a whole. So if I know one of them, I can subtract it from one and find the other probability. And mutually exclusive events cannot happen together. Now, non-mutually exclusive events can happen together. Plenty of cases. Now, to find the probability of A union B, we can add up the two probabilities, but we always got to subtract the intersection. Because if we have the probability, if we say that this is even, and then this is more than 4, or than B, then the evens we have 2, 4, and 6, and the more than 4 we have 4, 5, and 6, or just 5 and 6 if it's more than 4. The 6 is double counted. So evens are 2, 4, and 6. More than 4, it's 5 and 6. So we don't want to count 6 twice because it's in both groups. So the probability of even or more than 4 is 4 out of 6, where we could take the 3 out of 6, add the 2 out of 6, and subtract the 1 that's in the middle. Now I use the example of less than 4. Okay, so even and less than 4, there's an intersection. There's one that occurs, there's one number that's even and less than 4. So if I wanted to use this formula, I can add up the probability that's even, I can add up the probability that's less than 4, but then I got to subtract the intersection. I got to subtract the fact that I double counted the two. Now let's look at independent events. Let's take and explore this case. So I have a marble jar. It's got 12 green marbles and 8 violet marbles. And I have two different cases. Please read them. Write down what you think the probabilities are, and we can discuss them. So the first case, if I take a marble out and then put the same marble back in, it doesn't affect what the bag looks like. So when I'm picking the second marble, I still have 12 green and 8 violet. I still have 20 total marbles. The probability that the second marble is green is that there's 12 green out of the 20 in the bag because there's still the original 20 in the bag. This is called independent events, where the second pick is not affected by the first pick. Now, this second situation does depend on what I picked first. Because if I picked the first marble and it was green and I removed it, then I only have 11 green marbles out of the 19 that are remaining in the bag. But if I removed a purple or a violet, then I have 12 green ones still in the bag out of 19. So my probability changes depending on whether or not my first marble was green or violet. So if I remove events, if I change the denominator, I change my total, I'm generally looking at dependent events. Independent is when the first event does not affect the second event at all. So if I'm looking at two events and checking to see if they're independent, the outcome of the first event doesn't affect the outcome of the second event. Okay, dice, coins, great examples of this. If I roll a die and then I roll it again, or then I flip a coin, the coin doesn't think, well, what did the die say and what does the die tell me to do? Does the die tell me to be a heads or tails? That doesn't happen. Or if I roll a 1 and then I roll again, I'm equally likely to get a 1 or 2 or 3 all the way up to 6. Each event is independent, not affected by the other. So if we want the probability of rolling a 4 and flipping tails, these two events are independent, so I figure out the probability of the first event and multiply by the probability of the second event. So the probability I roll a 4 is 1/6. Probability I flip and get tails is 1/2. 1/6 times 1/2 is 1/12. If I wanted to list the sample space and say I can get a 1 with a heads and a 2 with a heads and a 3 with a heads, all the way up, and then 1 to tails and 2 tails and 3 tails, and have all the other events, I can do that. And say 4 tails, which would be right here, is my only winner. I can say I have 1 out of 12 winners. I can do it that way too. Or I can use the multiplication property of independent events. So now your turn to try a few of these. Pause the video, read, be careful, simplify your fractions if necessary, and show yourself that you can do this. Okay, so probability of picking a ball, purple or orange. There's 30 purple, 10 orange. There's 40 purple or orange, and it simplifies to 2/5. Not purple and not orange is the complement. Okay, if it's purple or orange, the opposite is not purple, not orange, which is 3/5, or 60 out of 100. Now, if I look at the intersection, okay, it doesn't say any of these balls are purple and orange, so the probability of purple and orange is 0. Doesn't exist. Okay, sometimes there will be overlap. This case, yeah, I should have definitely said that the balls are each only one color, and that would have clarified. More examples for you to try out. Show yourself that you can get these correct. Okay, even and not a 6. For this one, I would probably just list my sample space. So my sample space is 1 to 6, even and not 6. Even and not 6. 2 out of the 6 values, or 1/3. Then you roll a die twice. What's the probability of rolling an even number on the first roll, number less than 3 on the second roll? They're independent. So even is 1/2, less than 3 is 2 out of 6, or 1/3. 1/2 times 1/3 is 1/6. So if we know that they're independent, we can multiply the probabilities of each event together. And if we're still a little bit new to that, we can list the sample space, list all the possibilities, and circle or write which ones are successes, part over whole. That is what probability is, and we'll continue to do more. And we're going to learn about something called permutations and combinations in the next lesson.